Here we want to demonstrate another example for normal stress calculation. Okay. And in this problem, I want to demonstrate this problem because I want to show you once again the cut section method in the mechanics of engineering. Yeah, because the cut section method is very often used in the calculation of mechanics of materials. Okay, so let's see the problem. This problem want to calculate the stress at A B C point. A B C point. Okay, and it gives you the diameter of each section. Okay, and there's some external force here, 200 Newton here, 800 Newton here, 900 Newton here, and 300 Newton here. Okay, and okay, what's the stress, especially more specifically normal stress? What's the normal stress at A, B, and C? Okay, and here we will use the cut section method once again. Okay, and for the cut section method, okay, let's start. Okay, with cut section method. Okay, for this problem, you can calculate from. Let's see. Let's say, okay, you can calculate if for the cut section method, you can calculate from the right or calculate from the left. And okay, which way you want, calculate from the right or calculate from the left. Okay. Okay, this time I calculate from the left to see if it really works. Okay. Okay, so let's calculate from the left. Okay. Let's calculate from the left. Okay, the first I cut a section here, section A. Okay, so here we section A will calculate from the left. Okay, section A is here. Okay, and we cut section here. Okay, if you calculate from the left, that means you can ignore everything from the right. Okay, so on the right, I don't care anything on the right. I only care the left. Okay, left only have 300 Newton here. Okay. Okay, so I cut a section here, and we previously with internal force calculation, we say that in this cut section where we will have the normal force, shear force, shear force, and bending moment. And for this problem, we only have to consider the normal force. Okay. And don't forget this problem, you want to calculate the normal stress on each section. So don't forget the normal stress is equal to a normal force divided by area. So we need to calculate normal force on each section and then solve them. Okay, because it gives you a diameter, so we already know we can use the diameter to calculate cross-section area of each section. Okay, so let's see. Okay, so we only can consider normal force. So in the cross-section A, what normal force we need? Because normal force we can assume it's tension or it's compressed. Okay, but for your life easier, we just assume everything is tension. Okay, because the previous video I said no matter you assume it's point to the right or point to the left, no matter which direction you assume, finally you will have the same answers. Okay, so we just assume, okay, point to the right, everything is tension. Okay, so here, and do the force balance here. So we have 300 point to the left and plus NA point to the right equal to 0. So NA is 300. Okay, assume point to the right and it be a positive value. So that means it's really point to the right. Okay, so we finish this section. Okay, here and we go to the other section B. Okay, section B, what happened on section B? Let me draw the picture. Section B, B here. Okay, and here is 300 Newton, and here is 900 Newton here. Okay, so I calculate from the left. That means I ignore everything from the right. So anything on the right, I don't care. I only care everything on the left. Okay, and we also assume there's a tension force. normal tension, normal force at B. So it's MB. And do the force balance again. Just point to the left, so the minus 300. This is point to the right, minus 900. And we assume there's MB here and equal to 0. So what is MB? The normal force at B. Okay, normal force at B, we will have the it's 600, so minus 600. Okay, and we assume it's pointing to the right. We get negative value. That means the real direction is pointing to the left. Okay. Okay, finally the section C. Okay, finally section C. So what's section C? Section C is this one. Section C. C. Okay, assume NC here. And here's 300. And here's 900. And here is 800. Okay. So do the force balance again, minus 300 plus 900 minus 800 plus NC is equal to 0. So what is NC? NC is, let me see, minus 300 it's 100, sure, it's minus 200. So NC is 200, okay, and as soon point to the right, I get a positive value. So that means, that's really point to the right, okay. Okay, so here, so we got the force, and then we can use the force divided by area. It will equal to the normal stress. Okay, so let's calculate what's the normal stress at A. So it's 300, and don't forget the unit. The new unit is Newton. So Newton divided by area. So cross section area, it gives you a diameter. Be careful, give a diameter. So the area of circular area is pi over 4 and d squared. Okay, so it's pi over 4. What is d? D is 5 times 10 to the power minus 3 squared. Okay, so so in this problem, I think because last time I said it's 10 to the power minus 3 and squared because become 10 to the power minus 6. And it's a denominator, so it will become 10 to the power 6. Okay, so it's better to use the mega to express the stress, mega part to express the stress. Okay, so so what's the value here? So let's see. Okay, 300. Okay, so let's see, 25 times 3.14 divided by 4. And the fit is will equal 15.2, okay, let's say 9 megapascal. Okay, megapascal. Okay, so that's the stress at A. So so what's the stress at B? Okay, it's minus 600 and pi over 4 and 10 times 10 to the power minus 3 squared. So let's check. Okay, so that's again 3.14 divided by 3.14 divided by 4 and times 100 and inverse times 600. Okay, so it will become the minus 7.64 megapar. Okay, so what the stress at B? Okay, it's 200 pi over 4 and 10 to the power minus 3 squared. Okay, so what's the value? 3.14 divided by 4 times 25 inverse times 200. So it's 10.19 megapar. Okay. Okay, so I think that's the answer. Okay, that's the answer. Okay, and if you're interested, you can calculate from the right, and I think you will get the magnitude will be the same, but maybe here it becomes minus 15.3, here it's become positive 7.64, here it becomes minus 10.2 megapart. Okay, because you calculate from the left and calculate from the right, the magnitude is the same, but maybe you got a reverse sign. Okay, but that doesn't mean you calculate wrong, because calculate from the right, calculate from the left, calculate from the right. Okay, you must have reverse sign, because everything is static in this system, so there must be a negative sign. Okay, so try yourself. You calculate from the right, yeah, you will get a you got reverse sign in front of your answer. In front of your answer, okay, you got a reverse answer of this problem. Okay, okay, so this video just show you again the cut section method is used very often in this course. Okay, I just start the video here. See you in the next video. Bye bye.